Today's asynchronous session is on writing equations of lines in slope-intercept form given various pieces of information and also how to graph a line given the slope-intercept equation. First, we need to have a discussion about what slope is. Right? Slope just means the steepness of something. How steep something is. In this case, we're specifically talking about how steep a line is, and we quantify that with numbers. The higher the number is, absolute value-wise, the steeper the slope. So take a look at slope man here on the left. Lines that go up from left to right are said to have a positive slope. We assign them a positive value. Slopes that go downhill from left to right, we assign a negative value, so they have a negative slope. Vertical lines have an undefined slope, and we'll talk about that a little more in a minute. And horizontal lines here have a slope of 0. So this cute little face is a way to remember exactly what lines are positive, which lines are negative. The vertical lines are undefined, that makes his nose. And then horizontal lines have a slope of 0, as you can see on the face here. There's another way I like to remember it, and it has to deal with a skiing analogy. So suppose, look at this top landscape here that is perfectly horizontal. Right? If you were to put a pair of skis on and not push off, right, you would be going 0 miles per hour. So that's the way that I remember that if you're on skis at this horizontal landscape and you don't push off, you are going 0. So a horizontal line has a slope of 0. However, take a look at this guy hanging here on the sheer vertical cliff here on the bottom. So suppose this guy falls off this cliff. What's his face going to look like when he hits the ground? That's right, it's undefined. So that's another way I remember that a vertical line has an undefined slope. Just think about what your friend's face would look like if they fell off a sheer vertical cliff. It'd be undefined. So let's talk about how we quantify slopes, how steep something is. So if I was asking you, look at this guy, he's going skiing down this steep slope, but how steep is it? There's got to be a way we can assign a number to it to quantify exactly how steep this is. So we've thrown up a grid, and as what I'd like to do is I'm looking at the top horizontal line here, not this horizontal line, this line going downhill from left to right, which means it has a negative slope. So he's skiing downhill. This line has a negative slope. How big is this negative slope? Well, we define slope as rise over run. And rise can be negative. That means we can be going down, like we're going downhill here. Hence why we have this slope being negative and the slope that was going up to the right being positive. So I'm going to find where my coordinate plane crosses that slope in the back. So take a look. Here's a point here at 1, 5. And I'm going down. I'm trying to find another point that's close to it. And this point here is fairly close. So I'm going to go ahead and use these 2 points to talk about the slope of this line. So remember, we always do up and down first, divided by left and right. The vertical divided by the horizontal change. So here I go down 2, and then I'd go to the right 1, 2, 3 times. So we would say that this slope has a value of negative 2/3. So because we go down 2, that's a negative 2, and we go to the right 3, 1, 2, 3, and slope is rise over run, we assign this slope a value of negative 2/3. Alright, so we've been talking about linear equations here. The slope-intercept form, the standard form of an equation, the point-slope form, they're all the equations of lines. And we call those linear equations, and the word linear has the word line right in it. That's how I remember that when we say a linear equation, we are talking about the equation for a straight line. They use variables such as x and y, but what you won't have are any exponents, any square roots, any cubed roots. Because as soon as you do that, then you get curves, right? You get curved lines. And this is the equation of a straight line. So when you have a variable raised to a single power, it's being raised to the power of 1, not 2 or 3 or 4, then you have a linear equation. Now the most common form of the equation of a line is called the slope-intercept equation. That's the one that we'll see most often. It tells us if I get given an x value and I can use this equation to find the corresponding y value, the corresponding point on the line. So the m value that we're looking at here is called the slope, and it's just the m value, not the x included. So this is just a number. Remember, it's a number like -2/3 like we just got, or 4, or 5. And it tells us how steep the line is. And the b here is the y-intercept. It's a point on the graph. In fact, it is the point where it crosses the y-axis. So any point that is on the y-axis is called our y-intercept because it intercepts the line at that point. So this is the most common way to define a line, but think about what defines a line. Well, any 2 points would define a line because any 2 points that I draw, I can only connect them with one line. There's no other lines that I could draw that would go through both of these 2 points that I just placed on this axis. So 2 points define a line, so that's one way to do it. And the other way to do it is to give me 1 point that's on the graph and then tell me how steep the line is. Tell me the direction the line is going in. And that's what the slope does, and that's what the slope-intercept equation does. It gives me a point on the graph, specifically the one that's on the y-axis, and then it tells me what direction the line is going in with the slope. So another way to think about the slope is the rate of change, or the rise over run, like we just talked about. It's the vertical change divided by the horizontal change. And the y-intercept is where it crosses the y-axis, as we already talked about. So here's an example of an equation in slope-intercept form. And we just want to right now go ahead and identify what our slope is and what our y-intercept is by looking at the equation. So I know that it's in slope-intercept form because I have y all by itself on the left-hand side. Alright, so now I'm looking at, and we're going to identify the slope. And the slope is the coefficient of the x. In this case, it's the number then in front of the x. Now I don't see a number in front of it, but I see this minus sign. And remember, when we don't have a number in front of the x, there's an implied 1. So in this case, if I want to identify the slope in this case is -1. And if I want to identify the y-intercept, in this case, then it's at 4. So we can say that the y-intercept is at 4, and graphically that would mean that on the y-axis at 4 we have a point. We can also write the actual point right as 0, b, whatever that y-intercept is, right? Because any point that is on the y-axis is going to have an x-coordinate of 0. And so we can just look at what that number is at the end, what we call the b or the y-intercept, and we know that we have a point there. Okay, so find the y-intercept and slope of this line. Well, we know that the slope is the coefficient of x. It's the number right in front of x. And we can see that in this case, it is the 2/3. So we say this line has a slope of 2/3. But I don't see a b here. I don't see another number at the end. Alright, so when I don't see another number at the end, it's like I added 0. Remember, adding 0 doesn't change the value of anything. So in this case, we know that the slope of this line is 0. And recall from our discussion from our first slide, a slope of 0 is a horizontal line. So if I were to graph this line, I would go down to 2/3 on the y. I would go down to 2/3 on the y-axis and draw a horizontal line. A vertical line, sorry. So let's find the y-intercept and slope of this line. So here you notice that I don't have an x. Alright, and what that is indicating is that 3/2 is actually the b value. All right, because where's the m? Well, there isn't an m because there's no x, so we know that the m, the slope, must have been 0. So this is when we get our horizontal line. And the b value in this case is at 3/2. So in this case, we would have a horizontal line at 3/2. Okay, so let's talk about how to graph using the slope-intercept form. So I already have my equation here. It's already in slope-intercept form. The first thing we do with all of these equations when we're graphing, right, is we're going to identify the point first. I have to find a point, and then I use the slope information to get a second point, and then I can connect those points with a line. So here's our y-intercept at the end. It's telling me that it's +6. All right, so in this case, I know that the slope is -2. I know that it has a y-intercept of 6. So now I go ahead and I plot that 6 first. Remember, that's the first thing I do is I plot my first point. Now I'm going to use my slope information. Notice that I wrote -2 or -2/1 as a fraction. When we have a slope that's a whole number, we can always write any whole number over 1. And that kind of helps me determine how to get from one point to another, because remember, the top number is the change in y. It's our vertical change, the rise. And the denominator, the bottom number, is our run, the change horizontally. So when I put this -2 on top, that indicates that to get from one point to my next point, remember I'm starting at the 6, I should go down 2 and then to the right 1. So positive goes right, negative would go to the left, a positive on the y would go up, and a negative would go down. So we have a -2, so go down 2 and to the right 1. I make another point, and then remember, 2 points define a line. So this is really all I need. So then I can use a straight ruler, connect those 2 points with a line, and there's how we've graphed this equation. Notice that this line is going downhill from left to right, which we said indicates a negative slope. And we can see from this equation that the slope is indeed negative. How about we graph this line? Y equals -3x minus 2. So now just looking at this equation, jumps out at me already. I know that the slope is -3 and the y-intercept is -2. So a negative slope means it's going to go downhill from left to right. And it's going to be a steeper downhill than the line that we just graphed, because that -3 is larger absolute value-wise. So I'm kind of in my head already have an idea of what this line looks like. The only other piece of information I need to know is that it crosses this graph at the y-intercept of -2. Remember, always associate that sign immediately to the left as being the value of that number. So when we start to graph this, the very first thing that I look for is the b. I look for that slope, or that y-intercept, excuse me, and I put a point there on the graph. So we know that our y-intercept is at -2, so I plot a point at -2. And then now I can use my slope to get another point. And remember, -3 is the same as -3/1, so the rise is -3. That means go down 3. And then the run, in this case, is 1. That means go to the right 1. So we go down 3 and to the right 1 to get from one point to the next. All right, so notice how, remember, when I'm using the slope to find my second point, I start at that point. I don't start back at the origin at 0, 0. I start from my point that I plotted. And then now I use the slope to get a second point. So in this case, we did that. 2 points define a line, so I can connect these points with a line. And just how we predicted, this slope goes downhill from left to right and crosses the y-axis at -2. So how do we find the equation of a line given 2 points? How can we write that in slope-intercept form? All right, well, when we're writing the equation of a line, no matter what form we're given or what pieces of information we're given, we need to start out with the slope. If we're not given the slope, that's the very first thing that we need to find. So step 1 is always find the slope. We can do that by using our slope formula. Now we talked about how slope was rise over run, or change in y over change in x. So when I write this little y sub 2, this y subscript 2, all that's indicating is the y coordinate of the second point. And then I have it here subtracted minus the y coordinate of the first point. Now it doesn't matter which point I call the first point or which point I call the second point, as long as I'm consistent with how I do it. Because I wrote this point first, I'm going to call it the point 1. And I'm going to call my second point over here, the negative 2, 2, my second point. That could be flipped though, right? And it wouldn't matter. It shouldn't matter the order that I write a couple of points on, because it's the same 2 points, and I can only connect any 2 points with a single line. So the order that I write those points in shouldn't matter. Remember, you just got to be consistent. So this point right here, let's go ahead and show it. This y2 I've replaced with 2, and this is what I'm calling y2. Why? Because it's the y coordinate of my second point. So that means that this point here that goes with it, remember, is the x coordinate of the second point. This point here is the x coordinate of the first point, so we write it as x sub 1, and 14 is the y coordinate of the first point. So if it helps you to write out and identify which numbers are which, go ahead and do that first and then plug them into your slope formula. So in this case, this 2 is this 2 right here, because it's the y2. And then you can see I'm subtracting, that minus is always there, 14, the y coordinate of the first point. And then I go ahead and plug in negative 2 for my x coordinate of the second point, and I subtract the x coordinate of the first point, which in this case, so here's the minus, and then I plug in the positive 2. And then now I go ahead and use my subtraction of integer rules to subtract these two fractions, and I get that 2 minus 14 is negative 12, and negative 2 minus 2 is negative 4, and a negative divided by a negative is a positive, and 12 divided by 4 is 3. So we know now that the slope is 3. So we've accomplished goal 1, find the slope. Now we need to find the y-intercept, because remember, we're trying to write the equation, the line y equals mx plus b, and we just figured out our value for m, so we're halfway there, because remember, now we need a value for the b, the y-intercept. So how are we going to find the value of b? Well, we're going to use the fact that we know the slope, and we know at least 1 point on the line. In fact, we know 2 points on the line in this case. I'm going to pick one of the points. All right? And I'm going to go ahead and plug that in for my x and y, because I need an x and a y in order to figure out what that y-intercept is. And remember, so since we know what the slope is, when I plug in an x and y, the only variable that's left is b, and then we know how to solve for that. So in this case, notice how I picked the second point. I could have picked the first point. I would get the exact same answer. So I just picked one, and I picked the second point. And notice that where the negative 2 is, that's the x coordinate. I plug that in for x in the equation. Because remember, this is an ordered pair. Always the x first, then the y. Then I took my y coordinate and I plugged it in for the y. So don't get those mixed up. I see a lot of people will put negative 2 in for the y because it's the first number in their ordered pair. But that first number in your ordered pair is the x coordinate, not the y. So make sure you're plugging them in into the right spots. Okay, so I used the point that I chose along with the slope. And notice now that the only variable left is b, the y-intercept that we're solving for. So we're going to go ahead and solve that. So from the previous lessons, we know how to solve this. So I go ahead and do my multiplication of 3 times negative 2 first to get negative 6. And now I'm at a one-step equation, where to isolate b, I just need to add 6 to both sides of the equation, and we get that b is 8. So now notice we have every piece of information I need to write the equation of a line, because to write the equation of this line in slope-intercept form, all I need is to know is the m, which is the slope, and the y-intercept, or the b. And we have both of those numbers now. So I'm going to go back to my original equation and just replace the m and the b with the values that we found. So notice that where the m is, I plugged in a 3. And where the b is in our slope-intercept equation, I plugged in the 8 that we found. And then we will go ahead and write the equation as y equals 3x plus 8. Remember, the x and the y always stay there because they represent points on the line, and on a line that goes on forever and ever, there's an infinite number of points. So using this equation, if I pick an x value, an x coordinate, any one I want, I multiply it by 3 and add 8, and I'll get the y coordinate that goes with it. So we could find any point on the graph that we want. Suppose we have this table and we want to write an equation in slope-intercept form. So now we're looking at a table of values. All right, and we're trying to decide what the equation of the line is. Well, first of all, I want to check to make sure that this data really represents the equation of a line. So notice how we have equally spaced x-coordinates. They all change by 2. So that's what I want to see. And then I want to see that the y values that go with it are also equally spaced, meaning you're adding or subtracting the same number to go from one to the other. And notice to get from -6 to -3, I do have to add 3. And then from -3 to 0, I add 3. Then from 0 to 3, I add 3. So since we're going up by the same amount each time, I know that this is a linear equation and that I can write it in slope-intercept form. So just like last time when we were given 2 points, my first step was to try to figure out the slope. Right? We need to find the slope first. So we're going to pull out our handy slope formula again, because given a table of values of points, we clearly have at least 2 points that we can use to plug into our slope formula to find the slope of this line. So I'm going to call this point on the right here that I picked. I could have picked any 2. Remember, it doesn't matter. They don't even have to be right next to each other. As long as I pick 2 different points, it would work out and we'd get the same answer. So I just picked these 2 in the middle. So in this case, notice that I'm going to go ahead and call this point right here. Remember, this is my xy pair, 2, 0. That's one point. And right here, 0, -3, that's my second point. And if you want to write it out just how we did in the previous problem, you can, if that helps you more. So if I want to write out that I do have the ordered pair 0, -3, and then I want to write out that I have also another point, which I happen to pick as the 2, 0, right? We can write them out this way and then do it just how we did the last example, where I go ahead and I assign one point being called the first point and one being called the second point, and then that would make this x1 and the -3 y1. The 2 would be my x sub 2, and the 0 would be my y sub 2, the y coordinate of the second point. Alright, so now that I have this information, I'm going to go ahead and plug it into the equation. So I chose -3, I plugged in for y coordinate of my second point, and then I'm going to plug in the y coordinate of my other point. In this case, I called it this one, and it's 0. Notice how I kind of flipped it from different. Before I called this one 0.1 and then this one 0.2, and then I filled it in the equation as if this is the second point. Remember, it doesn't matter what you call it as long as you're consistent. So if this is going to be my y coordinate of my second point, then this has to be the x coordinate of my second point, the x2. I can't decide to use this point first on top and then switch it and use this second point first on the bottom. It has to be consistent. As long as you're consistent, you're going to get the same answer. So in this case, I went -3, so I'm going -3 minus 2 in this direction. So then on the bottom, I also have to be consistent. All right, -3 minus 0, sorry, y to y. And then we're going to go x to x, so 0 minus 2 on the bottom. Alright, so you can do that. So the y is on top, -3, you can think about it as we're looking at the table, -3 minus 0 divided by 0 minus 2. As long as we go in the same order, we're fine. So we go ahead and simplify that. We're going to get -3 divided by -2. And remember, a negative divided by a negative is a positive. So I rewrite this as +3/2. All right, so now we have the slope. So that's piece of information number one that we need. Then I always think back to my equation, y equals mx plus b. The missing number is the b, the y-intercept again, because now we have the slope. We just need that one other piece of information. So I'm going to go ahead and use this equation to plug in the slope along with one of my points. And it can be any one of the points on from the table. Okay. So in this case, we know that the y-intercept is the value when x is 0. The y-intercept in this case is going to be 3. We can get that, in fact, by kind of cheating and looking at the graph. And that's what was done here. Because we notice that, hey, when x is 0, 0 times anything, the m here is going to be 0, and then we're left with y is equal to b, which is, remember, 0b is the y-intercept. So because the table included the x value of 0, we kind of got the y-intercept for free. So we could kind of look at it and just say, oh look, it looks like the y-intercept is -3. So that is actually enough to write the equation of the line right now, because we know that the slope that we figured out was 3/2, so we plug that in for m. And we know that the y-intercept was -3 by reading it from the graph. The table. Suppose the table didn't include the y-intercept, so it didn't include the point when we had an x of 0. Well, then it would have been just like we did in the last example. I would have picked any one of my other points from the table and plugged it in for x and y, then I would have had to solve for b. Alright, so take a moment, pause the video, and see if you can write the equation of a line that has a slope of 4 and passes through the point 3, 2. Your first step should be to write the equation y equals mx plus b. Remember, try to fill in the slope. That's always step one. And then see if you can have enough information to figure out the b, the y-intercept. Alright, so I start off by writing, like I said, y equals mx plus b. And I'm asking myself, man, I need to get the m, I need to get the slope first, and then I'll worry about the b second. Well, we can read from this problem that the slope is already given to us. They say write an equation of a line with a slope of 4. Oh great, so I don't have to use the slope equation this time. It's telling me that the slope is 4. So right here where the m is, I already know I can replace that with a 4. So I'm halfway there. I'm halfway to writing this equation. The next piece of information I need is the y-intercept. So I need to be able to get that number somehow. And the way that we do that is we can plug that point, the point 3, 2, in for x and y along with our slope. And the only variable left is b. And since we only have one variable in this equation, we can solve for it. So notice the 2 is the y-coordinate. So it's going here. It's going first. It's going where the y is on the slope-intercept form of this equation. And the 3 is the x, and it's being plugged in for x. And then I go ahead and I replaced the m with 4. So now we can solve this equation. So I start off by saying 3 times 4 is 12. All right, replacing that with 12. And now I need to isolate b, and it's being added to a positive 12. So to undo that, to do the opposite of adding 12, we have to subtract 12 from both sides. And we get that our y-intercept, our b, is -10 because 2 minus 12 is -10. Now we have all the pieces of information we need to write the equation of the line and slope-intercept form. We have the slope that was given to us, and we just figured out what the b was, what the y-intercept was. So I go ahead and plug those values back into our equation, and I get that the equation of this line is y equals 4x minus 10. So that concludes this section on slope-intercept form. Make sure to go back to your course announcements and answer the asynchronous session 2 questions. If you have any questions, please email or message me. Thank you.